Yeah. Okay, so let's talk about Project 3, which is probably really why you came to class tonight, but I made you learn about pair programming and doing katas and stuff. Yeah. Okay, so yeah, the projects come fast and furious in this, I don't know about furious, probably more like, a little peevish, but anyway. Project 3. So, Project 1, you implemented your basic classes for your phone bill, and Project 2, you start working on a text file. Project 3 builds upon that by then adding the ability to pretty print a phone call. And what this has meant you to give you experience with is working with Java facilities for sorting, and then also for formatting dates and times. So you've got all the stuff from Project 2. So you've got your domain classes like phone bill and phone call. You've got your text dumper, your text parser, and now there's some new functionality that that you need to add to that. So in addition to so in Projects 1 and 2, it was perfectly fine to store the start time and the end time associated with your phone calls as strings. Right, you ran them in from the command line, maybe you did a little validation on the string, but we didn't care if it was like the 31st of February or the stuff was wrong, or if you had a month of 27, didn't matter. But in Project 3, I want you to start getting experience with the Java util date object, and so you'll do that by overriding get start time and get end time, which are two methods that are inherited from abstract phone call, to actually use the date object. And so you'll be learning about that. I'd also like you to change the behavior of your get start time string, get end time string methods to return the strings that are formatted using an object called dateformat.short. And you can learn all about that either in the Java I/O lecture part 2, the Java util lecture part 2, or you can go read the Java docs, whatever. So you'll be getting some experience using dates with that, and I'm guessing that some of you already started using them, but now it's a requirement. There's also some new requirements of the phone bill class, namely that the phone calls in the phone bill should be sorted chronologically by their begin time. And there's some additional logic here. So if you get two phone calls that begin at the same time, they should be sorted by their caller's phone numbers. And then phone calls that begin at the same time that come from the same caller, those should be considered equal. So not terribly complex sorting, and maybe not the way you do it in the real world, but that's good enough for the project. I recommend that you explore the comparable interface and have your phone call implement that. The nice thing about comparable is that it then makes your phone calls what are called naturally ordered, so they know how to order themselves with respect to each other. So that's all modifying existing code. Now there's a new piece of code that I want you to write, which is called a pretty printer. Now a pretty printer implements the phone bill dumper just like your text dumper does. It's the same, it implements the same contract. It takes a phone bill and dumps it out someplace. But now instead of dumping it out to a text file in text file format that can be easily read by a computer, namely your text parser, Pretty Printer is meant to generate just a representation of your phone bill that can be read by a human. It needs to look nice. So this gives you an opportunity to work with some of Java's utilities for text formatting, and in particular, date formatting. So there's a date format class that you can use to make the dates look nice. And your Pretty Printer should also include the duration of each phone call in minutes. So the format of the Pretty phone bill is completely up to you, but I encourage you to here again, experiment with and learn about some of these ways for formatting text in Java. And all of this is driven by a Project 3 class that has all the functionality of the previous projects. So the ability to create a phone call and add it to a phone bill, which may be read and written from a text file. And now you've also got a new option called -pretty, which will pretty print the phone bill to some destination. So if the file option is the character dash, it should pretty print the phone bill to standard output. That's sort of a Unixy thing to do. Otherwise, the name of a file to which the to which the phone bill should be pretty printed. So it has the ability to print the phone bill to both a file and standard out, depending on what the value of that file argument is. And that's it. And that's all you need to add for Project 3. A couple of notes here. The phone bill should be pre-printed after the phone call has been added, so I want the phone bill to contain all of the phone calls, not just the ones that were read from the text file. And oh yeah, heads up, I've changed the format of the date and time, or the time. It's no longer 24-hour time, it's now 12-hour time, and so then you've got so your dates are going to be 3 command line arguments now, the date, the time, and then an AM or a PM. Error handling is about the same as it was in the last project, so if there's something wrong with your command line, or if the format of the date or time on the command line is wrong, or if your text file is messed up, you should complain there. Also, this is an opportunity, I know some of you have asked about this. In this assignment, a phone call's end time is required to be before its start time. So it's another thing that now you're working with dates, it's a lot easier to do that. And so now we're able to validate that functionality also. Project 3 is due 2 weeks from tonight. We're at that point in the course where you've got a lot of stuff all going on at the same time, right? You're doing your Project 2, which is due next week. You're hopefully working on the cones some more, and now you're getting Project 3. It's a lot to handle, but hopefully you can keep up with it and figure out how to pace yourself so that you can keep up with the work. Any questions about Project 3? Yes?
So, video printing, you told that it should be standard out or it should be in the file.
Yes.
So, like, how are we managing that?
To reiterate, the way your program knows whether to print out to a file or standard out is when this file argument is a dash. So when the file is a dash, you print to standard out.
It's file dash. Or
Yes. So dash pretty dash. Ask me a question about that on the Google Plus group, and I will implement a integration test that demonstrates it, because it's something that people always ask about. So, but you got to ask me first, because I'm never going to remember. Now, I might remember. I'm just not going to do it. Anyway. Okay. Anything else on Project 3? Okay. One other thing. Where'd you go? Who asked about the cone? There you go. Yeah, there you are. Okay. Oh, sorry. Do you have a question about something else?
No.
Okay. Okay. So one last thing before we go. There was a particular cone. What remember the name of it? Was it like Lambda cone or something? Streams cone?
Streams.
About streams?
About streams.
Okay.
But there's also.
About lambdas probably or
I
something?
think so. Yeah.
Okay. So one of the lectures for tonight is all about Java 8. Java 8 was sort of a watershed release for Java. For the first time in it was almost 10 years, they made significant changes to the language. The kind of thing where it's like, oh wow, programming in Java is really different. The changes in the language also changes in the APIs. There were some very significant new APIs they introduced. The change in the language introduced the Lambda syntax. So those of you who have taken a course in functional programming have probably talked about lambdas and currying and all of that other stuff. And there's some very nice things about it. And so for a number of years, people tried to figure out, okay, how can we effectively add the power of lambdas where you've got sort of a nice syntax for calling functions into Java, which has all of its baggage and stuff. So they did it, and it was there in Java 8, and one of the cones is all about it. I'm trying to think, how can I... Okay, so here's what I'm going to do. And so I guess what I'd like to do is spend a few minutes walking through this one, because I think it's kind of important, and it's kind of an advanced topic. And someone asked me to do it, and I said, sure, why not? So, let's go back to the cones. Let's Maven Java exec, I think is how you run it. Exec Java. Oops. Oh, really? What does that mean? I didn't want that. Sorry, escape T. There you go. Okay. Okay, so where am I at right now? I'm like about assertions or something. So what's that file called? No. There's a one of the files. There's an XML file. Path to Enlightenment. There you go. So if you want to skip ahead in the cones, here's how you do it. You copy out everything. You comment out everything until about lambdas. So you comment out that, and where are lambdas? Java 7, Java 8. Okay. You do that. Okay. So now, if I do this, I should be at lambdas, or whatever that first one is. Default methods. Whoa! Oh, I didn't. I've commented too much. Yeah, sorry. Nope. Yep. There we go. About optional, about default methods, local time, lambdas. Okay. Once more with feeling. Okay, about lambdas. Great. Very simple lambda. Okay, about lambdas. Okay, very simple lambda. Okay, so what a lambda is, it's syntactic sugar for an anonymous inner class, which I guess I talk about in what? In the reflection lecture? Anyway, so there might be a way for me to convert this into something else. Oh yeah, expand lambda method to... Oh, there we go. Okay, no. Replace lambda with an anonymous inner class. So there's this syntax in Java that allows you to declare a class inside another class. And so here I have, there's an interface called runnable, and runnable has a single method called run. This is decompiled, I guess. It has a single method called run. And it's nice, sort of a general thing. It's like, hey, this is any object that can be run. Okay? And I'm saying, great, I want this R8. I don't even know why it's called R8. Rate, maybe? Yeah, I guess. And it's it basically says, hey, I am creating a new object that implements this runnable interface, and the run method on that object assigns a value to this static field called str. So this is the way you could do it before Java 8. In Java 8, they introduced this new compact syntax in the Lambda as this. Basically meaning that this is the implementation. Sorry, let me go back and do that again. This is how you can see it sort of side by side. So the runnable R8 in Lambda mode, this represents this run method right here, meaning that this says, hey, there's a single method on that interface that I implement, and the implementation of that method is str equals change in Lambda. And so if you expanded that out, this is what you get. You get all this boilerplate for saying, hey, I've got a new runnable. Yeah.
This is strictly because the runnable interface only has one method.
Exactly. Because the runnable interface only has one method. If you have an interface with multiple methods, you can't do it. So right, so when you have, and you have this all over Java, where you've got one interface or one class maybe, I don't know if classes work, but certainly one interface, when you've got one method, you can then use this compact lambda syntax to represent an object that implements that method with a particular implementation, particular algorithm. So that's what you get right here. And there are all sorts of interesting language rules with regards to this. So this creates this object whose run method will be this. So when you call the run method on this, what will string equal? Yes, changed in Lambda. So basically what you're doing when you call run, you're invoking this code right here. So let's see if that worked. Yes. Okay. So now we're, okay, simple Lambda method. That was a very simple Lambda. Here's a not so. Sorry. Yep. So, do you have a question? Are you pondering? Okay.
I didn't want you to move it.
Yeah, I know, right? Yeah, going fast. Okay. Yep.
Is that binding? persist if you pass out the lambda to another function?
Yes. The lambda itself, and here again, the way I think of it, because I learned it the old school way, is when I see this, I always think of the. Sorry, here again. I think of this. It's like, aha, that lambda that creates an object, and that object has one method on it, and when you invoke that method, you do that thing. So that's an object. You can pass it around wherever you want, right? There's nothing really anything fancy about it. Okay.
So,
yep.
I guess that's just. Do they have regular? I don't want to say regular, but like traditional Lambda kind of syntax where you don't have to have some weird interface where you can essentially assign a function to a variable?
Well, that's essentially what you're doing, but the Java way of doing it. So yeah, they don't have function pointers. They don't have.
But that requires that runnable interface, right? So if I just wanted to have some.
It's an object, yes.
Increments thing, I would have to have an interface that had some increments function first.
Because you would have to call a method called increment.
Yeah.
Yep. And the same thing for, what are some other examples? Maybe we'll see some here. But yes, it's just syntactic sugar. So, and this is one of the criticisms, a valid criticism of it, is like, hey, you're not doing anything special. So, I'm sure there's some, gray-haired professor there with, with the elbow patches on saying, this isn't a real functional language back in my day when we programmed in Lisp. Well, yes, sir. Yeah, okay, right. So that's cool, that's fine, that's valid, but this is Java, and everybody gets to use it now. So, yeah, sorry?
Is the C# world is like linked to SQL?
I don't know that much about link to SQL, but yeah, I know that in C# had this functionality way before Java ever did, and does it better from what I understand. But yeah. So I don't know exactly how. I don't know how they're the same and how they're different.
So maybe an F#.
Oh, and I'm sure F# then also has very similar concepts. It probably does things differently. Yeah. Okay. So here again, it's this syntactic sugar over saying, hey, this is like a method implementation that you can pass around. So simple lambda. Okay, we've got another lambda expression, but instead of having 0 arguments, we now have 1 argument to that function, to that method. That's a string, and here I can replace this. So there's this caps class, which is an anonymous, or rather an interface here. It has 1 method. It's called capitalize. It takes a string and returns a string. So now, here, if we were to implement it using anonymous inner classes, we say, aha, the implementation of that capitalize method is to say, take a string n and say to uppercase. Well, look, you've got 6 lines of code here. With a lambda, now it's only 1. Well, okay, 3. You could put all in 1. But the whole idea here is that you've got here again kind of this like anonymous function that takes a string called n as an argument and returns n.toUppercase. Actually, this is actually saying some more things. So it's saying, aha, this lambda can be replaced by an expression lambda. So let's change that and see what else we got. Okay, so there are a couple of variations on lambdas. There's the lambda that actually takes a code block here, and that way you could have more stuff. You could you could say, I don't know, well, hey, you could do something like this. We can put that into a variable, upper. And you can have that. So you can have multiple lines of code inside a lambda with that block. Although, but there's also this convenient syntax that if you do only have one line, you can just have the lambda expression be that one expression, that one statement. So here again, it's sort of a nice syntactic thing. Yes.
So I guess not to be negative, but why would I want to do this as a if I have to write the interface up there anyway, why would I not just write the function or the method that does the same thing? Like
for this cone, absolutely. That's the thing about the cones, though. It's like they are really simple. Perhaps when we get to the streams, we'll see that with the streams API, there are things like a predicate that will that represents a function that takes 2 inputs and returns a Boolean, and they want to express that as an interface. And so that's just the way it is, right? I mean, there's an interface there that specifies the contract for that. And then you can use a lambda to provide a function that satisfies that contract efficiently in a space compact way. So when we call the capitalize method on caps, what do we get? James, I guess. Yep. Okay, simple succinct lambda. Okay, so this points out that you can have, in your lambda expression, even though you have a parameter, you don't need to declare it that way. So here you can just say, it's the same thing here, but instead of declaring that you've got declaring the type of your parameter to the lambda, you can just declare that you have a parameter, right? And the compiler will infer the type based on the method signature that you're really invoking, right? So then if we convert this to an anonymous inner class, yep, then it sort of puts in everything. And so the compiler can infer all of this stuff, though. And if you have like the wrong type, it'll give you an error. So, again, so if we capitalize Arthur, we get Arthur. Oops. That's the French spelling. Okay.
What commands are you hitting to open up those options to expand?
For me, it's Alt return. So it's the, I don't know, quick fix. I don't even call that. Is it? Actually, does it tell you down at the bottom? Yeah, show intentions action, and that's Alt return. Oh, what?
It's just there.
Oh, okay. It's getting like sorry. Okay. Lambda Field. What is Lambda Field? Okay, Lambda Field is a field of type type caps. Notice that the lambda, you can use this variable. It's right. It's really inside here. Again, it's it is a class declaration, and you can reference this inside the anonymous inner class declaration. So when I go back here, so this dot lambda field, capitalize, really? Empty string? Well, that's super weak. Does that do something that I think it just says this dot toString? Oh, this dot toString. Wait, so what does it think it says? Caps. So this dot lambda field dot capitalize, and it returns. It's expecting the word caps. Well, that's interesting. How does that work? This dot lambda field, it calls this dot toString. Oh, that returns caps. Okay then, that explains it. These cones are hard. Wow. Okay, cool. That should work. Lambda field 2. Okay, this is the same thing. toString lambda field. And now you can just call, yep, toString directly, sort of the same thing there. And so now that's just going to be caps again. Cool. How many more of these have to go? Only a couple. Okay. Okay. Effectively final. That's weird. Okay. Right. Gotcha. One of the things about anonymous inner classes is that when they reference a variable in the same method, that you have to declare that that variable to be final. I go into some detail about it in one of the lectures. Your IntelliJ will tell you that you need that, and so just like believe it. But when they added lambdas to the language, they didn't require that lambdas reference fields. It essentially makes them what are called effectively final. You can't change it. So, so for instance, I mean, what happens if I try to say effectively final equals new value? Oh, look at that. Saying variable using lambda expression should be final or effectively final. So I can't change it. Now, there are kind of esoteric language rules why that's the case. I'm not going to go into them right now, but this is what it means to be effectively final, that I can't change it after it's used in a. Actually, can I change it before it's used? Oops. No. Okay. Again, I can't. Huh. I wonder why that is. What does that say? Already assigned to this value, so that's just telling me a warning. But now it's saying, hey, it should be final or effectively final. Okay. Nice. So then this thing becomes, I'm effectively, I think, effectively final, because we call it 2 uppercase. That doesn't look like it's... Excellent question. It's final. This variable is final. How come I can capitalize it?
Changed it and then changed the status of it essentially. So, right?
Sorry?
So it goes through the lambda function, and then the output, the lambda function essentially locks it, right? Like makes it a final. It's the action
Yes.
through that makes it a final or effectively final thing.
Yeah. At this point in the code, what does the string effectively final? What is this value? All caps?
Oh, you did capital. Oh.
Isn't like calling effective found isn't it any effective use function that would return the string? So isn't it
Yes.
modifying it?
Exactly, yes. So 2 uppercase returns another string. It doesn't affect. It doesn't. Well, it certainly doesn't change the the object referred to by the effectively final field. Instead, what it does is it takes that and then returns another string on it. But right, tricky. These are good questions. This is exactly what I expect you to be learning from doing these codes. Is asking yourselves like, why does this work, or like, why doesn't this work? And oh yeah, here's why. Okay, fun, right? Because if I try to do this, it's going to complain. It's like, hey, I expected the lowercase, but I got the uppercase. So this is still, I'm effectively final. Yep, now it's on to method reference. Oh, there's even more syntax. Okay, so kind of a cool thing that they added was the syntax to refer to a method. And basically what you can do is say, is you can assign this method reference to one of these, what are they called, functional interfaces. A functional interface is an interface that only has one method. So caps is what's called a functional interface. And because you have 2 uppercase, so the method 2 uppercase, which has a compatible signature with the caps method, and here again, let's replace it with a lambda, replace this with an anonymous inner class. Right? Caps has a capitalized method that takes a string and returns a string. And so then 2 uppercase, well, s.2 uppercase, there's a string here, and it returns, so it takes a string and returns a string, and because of that, those are assignment compatible. Okay? Right? Okay, so there's all this language stuff that you can do. So then let's see here. When I call caps.capitalize, what do I get? Gosling! Which is James Gosling, not Ryan Gosling. Okay, guys? I'm just saying this. I get the 2 confused myself? Okay. Yeah. Okay, here's another fun one. Oh, okay, good. Here's the function. So function is okay, yeah. Function is a functional interface, and it has a method called apply, which takes some type T and returns some other type R. It basically transforms one kind of object into another kind of object. Not be the same, but it transfers one into another, right? And so, fans of functional programming will probably recognize this. So, okay, here I have a function that takes a string, turns it into another string, and what do I have? Well, I have a lambda expression that takes a string s and turns it into the other string, which is represented as s plus this dot field field foo, which has a value of lambdas, plus that same string again. So if I say foo.apply, so foo is this function here, and I apply this function to the string pipe, what do I get? Pipe is the S here, so you get pipe lambdas, yep, lambdas, pipe. Yep, and that worked. Language syntax. This is kind of a weird one. It took me a long time to get used to it. Hopefully you guys will pick it up faster because you don't have years and decades of like dealing with inner classes and stuff. But like once you get the hang of it, it's a really very compact syntax. Yeah.
So that's what I would refer to as like the traditional Lambda thing. Is that some interface that they implement, or is that like a Java function?
This is a standard Java class. This is a Java util function.
Okay, so that's
Yep. Good call. Okay, so that's the Lambda language syntax. This is neat. What can you use this stuff for? Well, you can use them for something called streams. So the stream API, it's a lot like collections in that a stream represents, well, a bunch of objects all in a stream. But like conceptually, it could be an infinite stream. So imagine that you've got an application that processes information that's constantly coming in. So like the stock ticker, right? Oh, you have like new stock prices coming in all the time, or you have like a weather sensor, and like every minute it's sending, oh, here's the temperature, or here's the barometer. I don't know, whatever you do, right? You've got a whole bunch of information, and you want to, as the stream is coming in, you want to perform operations on this stream. You want to find, the highest value, the most recurring value. You want to take this big stream of data and reduce it into other pieces of data, right? So maybe you've got you're like not encrypting, compressing data or something like that, and it's coming in, and you want to perform some operation on it. The Streams API in Java gives you an abstraction that you can do all sorts of things with. So here we have a list, our old friend list, right? We learned about it in in the collections. Okay, we've got an array list of a whole bunch of Eastern European capitals, perhaps. That's neat. So let's see what you can do with this list. There's a stream method which returns a stream object for all of that. So you have your list, and now you're dealing with the stream for that list. And now we can explore the stream API. So the count method returns the number of items in the stream. So it'll consume the entire stream and return the number of elements. So for this stream, we have 1, 2, 3, 4, 5, 6. So we should have 6 elements in the stream. Expected 6, but with 6. It's a long 6. 6. Okay, that was also a deep 6. Okay. Okay. What else can you do with streams? I will get myself a stream, and there's a filter method. Now, filter takes a predicate. Remember what a predicate is? A function that takes some object and returns a Boolean, yes or no. It's like, does it pass this filter? Right, yeah. Predicate is like, okay, take an object and perform some operation on it and determine true or false. So here I'm going to say, give me a stream of that list and filter in all of the strings in that stream that start with the letter capital S. And filter then returns another stream, right? So here again, you're taking this stream of stuff, you're filtering, and what you get is another stream that with all that stuff filtered in, and you take account of it. Okay, so what should I expect? How many elements should I expect there to be in that filtered stream? 1, 2. Sarajevo and Skopje. Anybody know what the capital of that is? Or Macedonia. Excellent. Okay. Who knew? You did. I didn't. Luckily, this is in geography class. Okay. So you can use the filter method. Okay. Here's another one. Okay, there's a max method, and a max takes a comparator, and a comparator compares two objects and determines which one is larger. As a matter of fact, you'll be learning about that in the lecture all about about collections. Okay, so I want a comparator. And let's see here. So I want a comparator for the max function here. And there's a helper method on the comparator interface called comparing, which what? Takes a function. Okay, and it returns, okay. It takes a function that compares, what the hell does this do? This is where I always have to like go back into like, oops, give me the anonymous inner class. I can't make heads or tails of this thing. Okay, so it's a function, okay, oh, comparing. Okay, and so then comparing will, this takes a comparator of a bunch of strings, and comparing takes, I don't understand what that means. Takes a function that takes a string and an integer, converts a string to an integer. Okay, that's neat. And then I guess we'll compare all of those integers to see which one is the largest. Okay, that's neat. And so the way it does that is by, you've got an apply method that takes, you're going to apply this function, this transformation, to a string, and that's string.length. And that's abbreviated this way. This gets really confusing. Oh, look, and you can replace it with a method reference to make it even more confusing. So like when I look at this, it still makes me go cross-eyed. I'm like, this doesn't look like Java. It's not the 90s anymore. So it's, yeah. I know.
So for this, it's hard to see the usefulness of it. When you use like link to SQL, you don't even know you're doing it.
And in another 5 years, Java programmers aren't going to know they're doing it either. I think for me, the reason it's still so awkward because it's new and I'm old. But I think the same way that languages like C# have like just integrated functional programming into their APIs, this too will seem more natural when you're doing this kind of thing. Now, there is a certain class of application for which this is perfect, right? All the MapReduce stuff, all of the dealing with data at scale, concurrent programming. In the lecture about Java 8, I sort of talk about how all that means. This is elegant in the good way when you sort of get to that point. And I've used this kind of stuff in places, but I use it sparingly, right? These are the Koans. The whole idea is meant to teach you a concept. You probably don't want to be using this all over your code unless it makes sense to. Sometimes it is much easier to express it in sort of doing a for loop or something like that. It takes some getting used to, but it works. What?
Over like a query.
Right. So a database query. And so it's like, hey, give me all the results and then filter out, or actually not necessarily filter, but transform. And we probably have map here in a minute. So we'll get to map, and I think that's where maybe like over a query result. We'll see. Okay. So we say, hey, give me the max, and max returns an optional string, which means that there might not be any results of max, right? If you've got like a 0 length stream, you don't return, you return null. Well, null might be an element of the stream. So instead you have an optional object, which says, well, there might be something here. I don't know. You can ask if there's something there. And if the get will return the thing that's there. So here, the longest one is Ljubljana, Slovenia. Okay.
There's two longest.
Are there?
I think they're both 9 characters long. Yeah, the last two.
Ooh. So I wonder which one it returns.
First
Think it's the first one? That'd be my guess too. Yep, I think that's it, because this is now the min method. So that's a very good point. The max is probably undefined then. It could be either one, right? Because they both meet the criteria. So either you get the first one because well, actually no, there's no way, it would have to look at all of them, because max consumes the entire, you have to look at all of the elements in the stream. So then, this is true, this is correct, right? I guess it's probably implementation dependent. So in this case, it's probably not a very good test, because it's possible that a different implementation could return Sarajevo. What was the other one? No, Puerto Rico. Okay.
I guess it just doesn't update it if it's not greater than, like that's the common implementation.
Probably, yeah.
But that's like the,
But you shouldn't rely on that, right? It's or you should realize that there's going to be some variation. Okay, min, same thing, but you use the min, and min is probably going to be Zagreb.
Same situation.
Yeah, right. Yeah, same thing. There's two. Wow, this code is just all full of learning. What?
Not very good cone design.
Or it is, or is it? Right? Because it's like, oh, it's making you think. It's making right. I don't know. What is it? I know. Yeah, right. Why are we making you think at 9 o'clock at night? Yeah, right. Yeah. Okay. More and more and more. There's a lot more. And yeah, I think we're all getting ready to go. So anyway, this one in particular is different than the other ones. It's not just Java APIs. It's not just the same kind of language stuff that you're used to from C. Here you'll need to dig in a little bit. But I think it's interesting stuff. And it's things that not everybody's using, and it might help differentiate yourself on a job interview, or if they ask you to do some coding and you throw this in at the right time, they'll be like, aha, that person knows the language. Yeah.
Just a quick question on the schedule. Like week 5 is like D-Day. It seems like it's like project 3 due.
Oh, yeah.
Quiz 4 due. Midterm.
Okay, the midterm is a survey. It's not a big deal. So it's not like something you should worry about. But yeah, yep.
How much?
Midterm survey.
Like
4 points, just like everything else.
Okay.
Yep.
Okay.
Yep. So yes, week 5. So yeah, we're coming up to when you've got your cones due, and so hopefully by now you're well into them, right? And then all stuff's come due. Yeah.
What lecture material does quiz 3 cover for this week?
Which one is quiz 3? I don't know.
It's due next week. Like it's this week's quiz. And it'll kind of say like the topic, but it seems like they're like 2 weeks.
Oh, language API.
Just the core API.
Yeah, I think.
Like where you go over like util, I
Yeah.
Okay. Maybe. Awesome.
Language API. Then what's next? Okay, so this is probably Java Lang. I don't remember. And then Java I/O, and then the rest and stuff. So it's probably it'll last longer. Yeah. Thanks for staying late. Of course, you could have just watched it. Thanks for watching through all of this while I talk about that. Yeah, seriously. Yep. So anyway, those are going to be your quiz topics. That was worth a while. So yeah. So I think it's like stuff in the Java Lang package, and probably Java util also.
I was just I mean, we can see that from our video too.
Okay.
I was wondering if it was like a one-to-one correspondence with.
Approximately. So I think that's what you should be preparing for. Yeah, I think I try to. I don't remember how I have it sequenced with the projects, but it should be sort of the thing that you're thinking about for your next project. Okay. Yeah, how to get to be 9 o'clock. Damn it. Okay, anyway. So that's it for class tonight. I hope you had you learned a lot doing the tennis kata. We'll try another kata next week and see how it goes. See you on Google Community.